Here are the full solutions to a grade 10 math practice exam. The questions on this exam will cover topics including linear systems, analytic geometry, quadratics, and trigonometry. Follow along as I go through the solutions, and hopefully you'll see how you can get full marks on your grade 10 exam. Section 1 is multiple choice. There are 8 multiple choice questions. Question 1 says the midpoint of the line connecting point A to point B is, well, if I use the midpoint formula, I know I can find a midpoint by finding the average of the x coordinates of the two endpoints, and then the average of the y coordinates of the two endpoints. I'll make point A my first point, and point B my second point. And then if I sub into the midpoint formula, when averaging the x coordinates of the endpoints, I get 8 over 2, which is 4. And when averaging the y coordinates, I get 2 over 2, which is 1. So my midpoint is the point 4, 1. So the answer to number 1 is B. Moving on to question 2. It says, what is the equation for the circle centered at the origin with a radius of 4? The general format of the equation of a circle centered at the origin is x squared plus y squared equals the radius squared. So if the radius is 4, I'd have x squared plus y squared equals 4 squared. And 4 squared is 16, so I can see that the correct answer is D. Moving on to number 3. It says a circle has an equation of x squared plus y squared equals 36. What is the radius? Just like last question, the equation for a circle centered at the origin is x squared plus y squared equals the radius squared. So I can see from this equation that 36 is what the radius squared is equal to. To solve for the radius, I could square root both sides, and I'll see that the radius is equal to 6. So B is the answer for number 3. Moving on to number 4. It says, what is y equals x plus 7 times x minus 2 expanded? So to get it into expanded form, we can use FOIL, which is an acronym that tells us to find 4 products. The product of the first terms, the outside terms, the inside terms, and the last terms. When I find all of those products, x times x is x squared, x times negative 2 is negative 2x, 7 times x is 7x, and 7 times negative 2 is negative 14. The middle two terms are like terms. They can be collected together. Negative 2x plus 7x is positive 5x. So there's my expanded version of that quadratic. I can see the answer is part C. So the answers to my first 4 questions were B, D, B, C. The next 4 multiple choice. Number 5 says the axis of symmetry of this quadratic is, well, the axis of symmetry, if I have a quadratic, is the vertical line that goes through its vertex. The parabola will be symmetrical on either side of this. To find the equation of that line, I can use the formula x equals negative b over 2a. That formula is best when the quadratic is in standard form, which it is right there, where a is 5, b is 4, c is negative 55. Subbing into this formula, I would get negative 4 over 2 times 5, which is negative 4 over 10. Dividing top and bottom by 2 reduces this to negative 2 over 5. So the equation is D, x equals negative 2 over 5. Number 6 says you have a right angle triangle with a reference angle of 30 degrees. What is the measure of the third angle? Well, a right angle triangle means there is one 90-degree angle in that triangle. It also says there is a 30-degree reference angle. To find the last angle, I'll call it theta. I know the sum of the angles in a triangle add to 180, so I know 90 plus 30 plus theta would have to equal 180. To solve for theta, I could just subtract those two angles, 90 and 30, from 180, and I figure out that the other angle must be 60 degrees. So that's part C. Number 7 says, which trig ratio would you need to use to find the length of x? You'll need to remember the acronym SOHCAHTOA, and also in a right triangle, how to label opposite adjacent hypotenuse from your reference angle. The reference angle is 34. The side opposite from that is side x. The hypotenuse is always across from the right angle, and the side adjacent to the reference angle is this side right here. If you were trying to solve for x, you would need to use the ratio that involves that side and the side that you know. So the ratio that involves the opposite and the hypotenuse is sine. So our answer for this is A. Number 8 says there is one solution to a quadratic equation if And then it gives us a bunch of options that talk about b squared minus 4ac. Remember, that's the discriminant of quadratic formula. If b squared minus 4ac, which is underneath the square root, is equal to 0, you would be adding and subtracting 0, which is the same answer, meaning you would only get one solution. So the answer to this is A. If b squared minus 4ac was greater than 0, you'd have two solutions. And if it was less than 0, you would have no solutions. The answers to these four questions were D, C, A, A. Let's move on to the short answer part of this exam now. Section 2 is about analytic geometry, and I've lumped in the linear system questions into this section. Number 9 says solve the following linear system using the method of substitution. So here are two linear equations. I want to find the point of intersection of those two lines, or algebraically, the point that satisfies both of those equations. The method of substitution, I like to start by writing the lines beside each other, and then I like to choose a variable to isolate. If there's a variable that has a coefficient of 1, like that x, that's going to be the easiest one to isolate. And I'll isolate it by subtracting that 4y to the other side of the equation. So I'll have x equals 6 minus 4y. Since equation 1 tells us x is equal to 6 minus 4y, we can substitute that in for the x into the other equation, and then solve for what value of y allows their x's to be equal. So when I do that substitution, I'll replace the x with 6 minus 4y. And now I can solve for y. I'll start by expanding the left side of this equation. 2 times 6 is 12. 2 times negative 4y is negative 8y. I'll take both the variable terms to the right side of the equation, and I'll move all the constant terms to the left. Collecting my like terms, I have 11 equals 11y. Divide both sides by 11, and I see that y equals 1. I can now take that value of y I got and substitute it back in here for y, which will allow me to solve for x. So I'll have x equals 6 minus 4 times 1, which means x is equal to 2. So these values of x and y satisfy both of the original equations. That means that's where the lines would intersect. So we can say our point of intersection is the point 2, 1. Number 10 says to solve this linear system using the method of elimination. For the method of elimination, you're going to add or subtract the equations from each other to try and eliminate a variable. Before you can do that, you need the coefficient of either the x's or the y's to have the same absolute value. And we can make them have the same absolute value by multiplying one or both of the equations by a constant. So I should notice that multiplying this top equation by 2 would make the coefficients of the x's be the same. So I'll do 2 times the first equation, and I'll remember that I have to multiply all of the terms by 2, giving me 8x plus 6y equals 8. My second equation I can leave the same, and then if I subtract these equations from each other, the x's will eliminate. 8x minus 8x is 0. 6y minus negative y is 7y, and 8 minus 1 is 7. Isolate the y by dividing both sides by 7, and we get y is equal to 1. We can take that answer we got for y and sub it back into either of the original equations to solve for x. I'll sub it into equation 1. And now I'll solve for x. I'll start by isolating the term that has the x, and then divide both sides by 4 to get x by itself, and I figure out x is equal to 1/4. So my point of intersection is the point 1/4, 1. Moving on to question 11, it says to find the midpoint of each line segment that connects each pair of points that I have here. So as a reminder, I'll write the midpoint formula, and then to find the middle of 2 points, I just have to average the x's and average the y's. It doesn't matter which of these points you consider your first or your second. I'll label A my first point, so that's my x1, y1, and B is my second point, so that's my x2, y2. If I sub into this midpoint formula, I can see that when averaging the x's, I get 4/2, which is 2. And averaging the y coordinates, I get negative 10/2, which is negative 5. And then I can do the same thing for part B. I'll just show you the answer quickly. So you can see the midpoint of the line connecting C and D would be the point 4.5, 3.5. Let's move on to question 12, which is about circles. Part A says find the equation of the circle that is centered at the origin and passes through the point 3, -8. So that point is an xy coordinate that is on my circle. An equation of a circle centered at the origin is always of the format x squared plus y squared equals the radius squared. To write this equation, I need to solve for what is r squared, and I can do that by taking my x and y coordinates, subbing them in for x and y into the equation, and solving for r squared. That would give me 3 squared plus negative 8 squared equals the radius squared. If I do 9 plus 64, I get 73 is what the r value squared is. I don't actually need to square root this to get the radius, because to write the equation of a circle, I just need r squared. And I've got that. R squared is 73. So the equation of this circle is x squared plus y squared equals 73. Part B says, does the point 7, negative 7 lie inside, outside, or on this circle? I can answer this question just by taking this xy point, subbing it into x and y in the equation of my circle, and seeing if my answer is less than, equal to, or greater than 73. So I'll split the equation of my circle into its left side and its right side. The left side of the equation is x squared plus y squared, and the right side is 73. I'll now sub in my xy point, 7, negative 7 for x and y, and I get 49 plus 49, which is 98. Since 98 is greater than 73, I know that that point must lie outside of the circle. If it was less than 73, it would have been inside the circle, and if it was equal to 73, it would have been on the circle. Moving on, 13 says find the length of each side of the triangle with these 3 vertices, and then classify the triangle as either scalene, isosceles, or equilateral. We'll need 2 things for this question: the length formula and a rough sketch of this triangle. Using this length formula, I need to find the length of all 3 of these sides. Let's start with the length of side AB. The length formula tells me to find the difference in the x values, square it, the difference in the y values, square it, and then add those results. So I'll start with the difference in the x coordinates, negative 3 minus negative 1, plus the difference in the y coordinates, 3 minus 5. Negative 3 minus negative 1 is negative 2, and then when I square that, I get 4. 3 minus 5 is negative 2, square it, I get 4 again. So the length of AB is the square root of 8. I need to do this same process for the lengths of the other 2 sides. So the next side that I'll do is the side BC. I need to find the difference in the x coordinates, so 1 minus negative 1, square that, plus the difference in the y coordinates, 3 minus 5, and then square that. Underneath the square root, I've got a 2 squared plus a negative 2 squared. That's just 4 plus 4, which is 8 again. So the length of side BC is also root 8. Let's do the third and final side, side AC. The difference in the x's, 1 minus negative 3, I'll square that, plus the difference in the y's, 3 minus 3, and then square that as well. So underneath the square root, 1 minus negative 3 is 4, square that is 16, plus 0 squared is 0. So I just have the square root of 16, which is of course just equal to 4. So based on the lengths of these 3 sides, since 2 of the sides are equal, I know this is an isosceles triangle. So I can fill in the answer here. Triangle ABC is an isosceles triangle. Moving on to question 14. It says find the median from vertex B for the triangle that is formed by the connection of those 3 points. We'll write the equation of that median in slope y-intercept form, which is y equals mx plus b form. I'll start with a rough sketch of the triangle, and then let me draw what the median from vertex B would look like. The median from vertex B is the line that would go from B to the midpoint of the opposite side. And I want to write the equation of that line in y equals mx plus b form. To do that, I'll need the slope and the y-intercept, and to be able to calculate that, I'm going to need to know the coordinates of this midpoint. Let me start by finding the midpoint of this line that connects A to C by averaging the x coordinates, so add them and divide by 2, and also averaging the y coordinates, so add them and divide by 2. If I do those calculations, I figure out that the midpoint is negative 2, 1. So I now know this point here is the point negative 2, 1. So now I just want the equation of this red line, which is the line that connects those 2 points. Let me find the slope of that line using the slope formula, which is just change in y over change in x, or y2 minus y1 over x2 minus x1. So I just need to find the change in the y coordinates, 10 minus 1, and divide that by the change in the x coordinates, 2 minus negative 2. That gives me 9 over 4 as the slope of the median. I can now find the equation of the median in the format y equals mx plus b by taking my m value, subbing it in for m, and then choosing either of the points that are on my median and subbing in the coordinates as my x and my y, and that allows me to solve for b. I'll choose point b as my xy. So it would be 10 equals 9 over 4 times 2 plus b. And then if I solve this equation for b, I'll start by finding this product, or actually it might be easier if I reduce this. 2 over 4 reduces to a half. So I have 10 equals 9 over 2 plus b. We'll subtract this 9 over 2 to the other side. So I have 10 minus 9 over 2. Let me get a common denominator. This is 10 over 1. I'll multiply top and bottom of this by 2, which would give me 20 over 2, which leaves me with a b value of 11 over 2, or 5.5. So the final equation of the median would be y equals 9 over 4x plus 11 over 2. Let's do the next question, which asks us to find the equation of the right bisector of the line segment that connects point A to point B. Let me just draw a line segment that connects those 2 points. The right bisector of this line segment would be the line that goes through the midpoint of AB and intersects AB at a 90-degree angle. To write that equation in the form y equals mx plus b, I'll have to first find that midpoint. I need to add the x's and divide by 2 to find their average, and then add the y's and divide by 2 to find their average. If I evaluate each of those expressions, I get negative 2, 1 as the midpoint of line AB. The next thing I'll want is the slope of the right bisector. Since it's perpendicular to AB, I'll start by finding the slope of AB and then doing the negative reciprocal of that slope. To find the slope of AB, I can follow my formula y2 minus y1 over x2 minus x1. So find the change in the y values, 6 minus negative 4, and divide that by the change in the x values, negative 8 minus 4. This gives me 10 over negative 12, which would reduce if I divide top and bottom by 2. I could get negative 5 over 6. The slope of the right bisector would be the negative reciprocal of negative 5 over 6, which means flip it and change the sign. So I'll make it positive 6 over 5. Now I can write the equation of the right bisector in the format y equals mx plus b by subbing in the slope of the right bisector for m, and the point that is on the right bisector is this point negative 2, 1. I'll sub that in for x and y, and then solve for b. So I would have 1 equals 6 over 5 times x, which is negative 2, plus b. If I rearrange and solve this for b, I have 1 equals negative 12 over 5 plus b. So 5 over 5 plus 12 over 5 gives me a b value of 17 over 5. So the final equation would be y equals 6 over 5x plus 17 over 5. That brings us to the end of the analytic geometry section. The next main part of this exam is quadratics. Question 16 says, fill in the table to describe the transformations applied to each quadratic equation. So each of these quadratics I notice are in vertex form. And as a reminder, vertex form is the format y equals a times x minus h squared plus k, where h and k are the coordinates of the vertex. And the axis of symmetry, which is the vertical line that goes through the vertex, would just be x equals whatever the x coordinate of the vertex is. So it would be x equals the h value. Remember, h is what we are subtracting from x. So for the first table, it asks me for what the vertex is. I don't see a constant after the binomial being squared, so there's a plus 0 there. So the vertex is 2, 0. The axis of symmetry is x equals whatever the h value is, so x equals 2. Stretch compression value, I should remind you about that as well. And I could do that with a little number line here for you. To figure out if there's a stretch or compression, we look at the a value of the quadratic. If the a value is between negative 1 and 1, and of course not equal to 0, there's a vertical compression by a factor of the absolute value of a. But if a is bigger than 1 or less than -1, there's a vertical stretch by a factor of the absolute value of a. And another thing to note is if a is bigger than 0, the quadratic opens up. But if it is less than 0, the quadratic opens down. So with all that information, I notice the a value of my first quadratic is -1. When it's at -1, there's not a stretch or compression, but it does open down. So I can say stretch or compression, none. Multiplying by -1 doesn't make it bigger or smaller, but the direction of opening, I can say down. And the values x may take, that just means the domain of this function. So basically, what could we sub in for x and be able to get an answer? For a quadratic, the domain is always x is an element of real numbers, which means x could be anything. The range, however, what y values could this function output? Well, if we think about what this quadratic would look like, we know that this quadratic's vertex is at 2, 0, and it opens down. So a rough sketch of that, quadratic that opens down, whose vertex is at 2, 0. We know the y values of this function are always going to be at the y value of the vertex or less. So we could say y is an element of real numbers, given y is less than or equal to the y coordinate of its vertex, which is 0. Let's do part B. For this quadratic that's in vertex form, the vertex, remember, is hk, where h is what we're subtracting from x. So I see x plus 3 here, which means we must be subtracting a -3 to make it look like x plus 3. The h value is always the opposite sign of what you see in the brackets. So my vertex is actually at -3, -7. The axis of symmetry is x equals h, so x equals -3. Stretch or compression factor, well, if I look at the a value of a half, an a value of a half would be right here. That falls in the vertical compression section. So I can say a vertical compression by a factor of 1/2. The direction of opening, since the a value is positive, I know that the quadratic opens up. Values x may take is always any real number, so x is an element of real numbers. Values y may take, let me draw a rough sketch of this quadratic, right? This one, it opens up, and its vertex is at -3, -7. So when we're talking about the y coordinates, the y coordinate is always going to be at -7 or above. So I'll say y is an element of real numbers, given y is greater than or equal to -7. Let's move on to question 17, where given the description of the transformations, we'll write the equation. So it says, compared to the graph of y equals x squared, a parabola has been compressed vertically by a factor of a third, reflected in the x-axis, shifted left and 9 units up. Let's write the equation of the parabola. So I'll start by getting the a value. Since it's reflected in the x-axis, I know a is negative, and because it's compressed vertically by a factor of a third, that means the a value must be -1/3. Shifting 1 unit to the left means the x-coordinate of the vertex must be -1, so the h value is -1, and shifting 9 units up means the vertex must have a y-coordinate of 9, so the k value must be 9. So I'll sub those values into the vertex form equation, and when I sub all 3 of those in for a, h, and k, I get y equals -1/3 x minus -1 squared plus 9. But we wouldn't leave this as x minus -1. That's the same as just x plus 1. So there you have it. There is the vertex form equation of that quadratic. Number 18 says solve the following quadratics by factoring. So I've got a couple quadratic equations here. I want to know when is this quadratic equal to 0. So I'll get this quadratic into factored form. And since the a value of this quadratic is 1, I can solve this the short way. I just have to find two numbers that have a product of the c value, 35, and a sum of the b value, -12. The numbers that satisfy that product and sum are -7 and -5. So now that I have the numbers that satisfy the product and sum, I can rewrite that standard form quadratic in its equivalent factored form by adding each of those numbers to x in their respective factors. And that gives me factors of x minus 7 and x minus 5. Now I know the product of those two would be 0 if either one of the two were 0. So I'll set each of those factors to 0 and solve each of those little equations. And I get x equals 7 and x equals 5 as two possible solutions to this equation. You could check them both in the original equation to make sure it makes left side equal right side. And the question actually asked me to state them as the x-intercepts because they are the zeros of the parabolas. So the x-intercepts of that quadratic would be the points 7, 0 and 5, 0. If we do part B, this one's a little bit different because if we look at this one, the a value is not 1. So when that's the case and it can't be common factored out, we need to find numbers who have a product, not just of c, but of a times c. So 2 times 3 is 6. And still a sum of just the b value, so a sum of 7. The numbers that satisfy that product and sum are 6 and 1. But what we have to do with those two numbers is we have to split the middle term into a sum of 6x and 1x. And now we factor by grouping. I look at the first two terms and notice I could take out a common factor of 2x. When I divide them both by 2x, I get x plus 3. And the last two terms, all I could common factor out from that group is just a 1. Now I notice I have a common binomial of x plus 3, so I can common factor out the x plus 3 from both terms. And when I do that, I'm left with 2x plus 1 as my second factor. And now that it's in factored form, I can just set each factor to 0 to see how the product of those two could be 0. So set x plus 3 to 0 and 2x plus 1 equal to 0. Solving each of those equations gets me two answers, my first answer being -3, and my second answer, if I rearrange this, I get my second answer to be -1/2, which means the x-intercepts of that quadratic would be at -3 and -0.5. Let's move on to question 19. It says, solve the following equation. Round your answer to 2 decimal places if necessary. Whenever solving a quadratic equation, the first step should be setting it equal to 0. So let's move the 4 to the other side and collect it with that 2. And now solving a quadratic, you should always try and solve it by factoring first. We could look and see, are there numbers that have a product of a times c, so a product of 14, and a sum of the b value, a sum of 10. There are no numbers that satisfy that product and sum. So that doesn't mean there are no answers to this quadratic equation. It just means there are no rational answers. There may be some irrational answers. We'll have to check quadratic formula. So I'll remind you of quadratic formula off to the side here. If I sub my a, b, and c values into quadratic formula, I'll first want to simplify what's underneath the square root to see if I'm actually going to be able to get any answers to this. If I evaluate this, I get 44. So the fact that this is positive tells me there are going to be 2 irrational answers to this equation. My first answer, I could get the approximate value by doing -10 plus root 44 divided by -14. And my second approximate answer, I can get by doing -10 minus the square root of 44 over -14, which give me answers of 0.24 and 1.19 respectively. Question 20 says, based on the graph of this parabola, write the equation in factored form. Well, the factored form equation of a parabola looks like this. Y equals a times x minus m times x minus n, where m and n are the x-intercepts. So I see my x-intercepts are at 4 and 10, so those are my m and my n values. I also need some other point that is on this parabola. I see this point right here looks like the point to -8. I'll call that my xy point. So using these x-intercepts and this xy point, I can solve for a, my stretch or compression factor, which will give me the graph of this parabola. So when subbing in those values for m, n, x, and y, I get the following equation, and then this equation can be solved for a. I'll simplify these factors first. Their product is 16. I'll isolate a by dividing both sides by 16, and I figure out my a value is -0.5. So the final equation of this quadratic in factored form would be y equals -0.5 x minus 4 times x minus 10. Part B says to write an equation in standard form by expanding that factored form equation that we just made, right here. So I'll rewrite it. I'll start by finding the product of those two factors. Using the method of FOIL, I'll have to find 4 products. When I find those 4 products, I'm going to write that whole product inside of brackets so that I remember to distribute the negative a half to each of the terms. So when multiplying those two factors, I would get x squared minus 10x minus 4x plus 40. These two terms could of course be collected together to make a negative 14x, and then I just have to distribute the negative a half to all 3 of those terms. When I multiply all 3 of them by negative a half, I've got negative a half x squared plus 7x minus 20. These two equations are equivalent to each other, they're just in different formats. Question 21 says for this quadratic, find the x-intercepts using any method. Well, if I want the x-intercepts, I know at an x-intercept, the y value is 0. So I'll set y equal to 0, and then to solve a quadratic equation that's set to 0, I could try by factoring first. I notice the a value is not 1, but I could common factor it out from all 3 terms. So when I divide all 3 terms by 3, I get x squared plus 6x plus 5. And now this quadratic, its a value is 1, so it will factor easily. I just have to find numbers who have a product of the c value, so a product of 5, and a sum of the b value, so a sum of 6. The numbers that work are 5 and 1, which means that quadratic would factor to x plus 5 times x plus 1. And now the product of those 3 factors would be 0 if any of the 3 factors were 0. X plus 5 would be 0 if x was negative 5, and x plus 1 would be 0 if x was negative 1. So the x-intercepts are at negative 5 and negative 1. Part B says to convert the equation from the previous question into vertex form by completing the square. Then state the vertex and if it's a max or a min point. So for the process of completing the square, what you have to do to start with is common factor the a value from the first 2 terms only. So I'll divide the first 2 terms by 3, giving me x squared plus 6x, and leave the constant at the end. Oh, and I should remind you what the goal here is to go from standard form, which looks like ax squared plus bx plus c, into vertex form, which looks like a times x minus h squared plus k. So the big goal here is to get this binomial that's being squared. And to do that, I'm going to have to create a perfect square trinomial inside the brackets here. And how we do that is inside the brackets, we have to add and subtract a special number. The number that we add and subtract is half of this value squared. So half of 6 is 3, 3 squared is 9. So we add and subtract 9. We don't want the negative 9, we just had to put that to keep the equation equivalent. So we'll get it out of the brackets by multiplying it by the 3 that's in front. So that leaves us with 3 times x squared plus 6x plus 9, which is the perfect square trinomial. And then 3 times negative 9 is negative 27. When we factor the quadratic that's in the brackets, the numbers that multiply to 9 and add to 6 are 3 and 3. So it would factor easily to x plus 3 times another x plus 3, which I could just write as x plus 3 squared. And then negative 27 plus 15 is negative 12. So there's my vertex form. The vertex is hk, which would be negative 3, negative 12. And because the a value is positive, I know this quadratic opens up. So that vertex, negative 3, negative 12, is at the bottom of the parabola, so it is a minimum point. The last thing we have to do is graph this parabola on the grid below. So I'll graph the x-intercepts and the vertex. The vertex was at negative 3, negative 12. And the x-intercepts, let me look back, were at negative 5 and negative 1. And there's the graph of my parabola. The last section of this exam before the application section is trigonometry. 22 says find the indicated side length to the nearest tenth. Because both of these triangles have a 90-degree angle, we can use SOHCAHTOA to be able to solve for the missing side length. If we look at the triangle in part A, I see the known angle, which we call the reference angle, is 41 degrees. From that 41 degree angle, I'm going to label the opposite side, the adjacent side, and the hypotenuse. Hypotenuse is always across from the right angle. Opposite side is opposite from the reference angle, and adjacent is the one right beside the reference angle. Now we decide what primary trig ratio will allow us to solve for the missing side. If I want the opposite side and know the hypotenuse, the ratio that has opposite and hypotenuse is sine. So I can say that sine of the reference angle 41 degrees is equal to the opposite side, which is x, divided by the hypotenuse, which is 30. Isolate the x by multiplying the 30 to the other side, and then use your calculator to get an approximate value of 19.7 meters. If we move to the triangle in part B, the reference angle is down here, it's 43 degrees. From that 43 degree reference angle, I'll label opposite, adjacent, and hypotenuse. We're looking for the adjacent side, and we know the hypotenuse. The ratio that involves adjacent and hypotenuse is cosine. So I can say that cosine of 43 degrees is equal to the adjacent side, x, divided by the hypotenuse, which is 15. Isolate x by multiplying the 15 to the other side. We have x equals 15 times cos 43, and that's about 11.0 centimeters. 23 says find the indicated angle to the nearest tenth. We'll still be using SOHCAHTOA since these are both right angle triangles. Starting with part A, from the reference angle that we're trying to find, let me label opposite, adjacent, and hypotenuse. And when we're trying to solve for an angle, we'll need to use the two sides that we know, the opposite and the adjacent side. The ratio that has opposite and adjacent is tan. So I could say that tan of the reference angle equals the opposite 3 divided by the adjacent 7. And when we know the ratio and want the angle, we can get that angle by doing inverse tan of the ratio. And then using your calculator to get an approximate value for that, I get about 23.2 degrees. The triangle in part B, we're looking for angle B, it says. So we're looking for this angle. So that's our reference angle. From that reference angle, I'll label opposite, adjacent, hypotenuse. The sides I know are the hypotenuse and the opposite. The ratio that has opposite and hypotenuse is sine. So I can say that sine of angle B is equal to opposite 3 over hypotenuse 6.7. And when we know the ratio and want the angle, we have to use inverse sine of the ratio. And then your calculator will give you the angle that has that known ratio. So angle B would be approximately 26.6 degrees. The last thing we have left to do is trigonometry of oblique triangles. So there's no 90-degree angle anymore. Part A says find the length of side R. If I want the length of side R, well, what do we know in this triangle? We know two angles, which means we really know all three because we know the angles in a triangle add to 180, and we know one side. So when you know two angles in one side, sine law will allow you to solve for another side. As a reminder, sine law is A over sine A equals B over sine B, which equals C over sine C, which just means that if you take a side and divide it by sine of its opposite angle, the ratio is going to be the same for any side and opposite angle pair. So 8 divided by sine of 68 would be equal to R divided by sine of 57. So I'll set up those ratios, and then I'll isolate R by just multiplying both sides by sine 57. And that would give me R equals 8 times sine 57 over sine 68. And my calculator will give me an approximate value of 7.2 centimeters. Sine law also works when you know two sides of an oblique triangle and one of the angles opposite from one of the known sides. So it's across from the known side of 18. Sine law would tell me that 18 divided by sine of 80 would be equal to 16 divided by sine of A. So I'll set up those ratios. What I think I'll do now is I'll cross multiply 18 times sine A is equal to 16 times sine 80. And my goal is to solve for angle A, so I'll isolate sine A by dividing the 18 to the other side. And when we know the ratio and want the angle, we'll do inverse sine of that whole ratio to get angle A. And if I do that, I get about 61.1 degrees. And the last two triangles to work with, we're going to need cosine law for these two triangles. Let me remind you about cosine law. If in a triangle you're given two sides and the angle that is between the two known sides, this version of cosine law will allow you to solve for the third remaining side. That third remaining side squared is equal to, if we follow this pattern, it's equal to the sum of the squares of the two known sides, so 14 squared plus 11 squared, minus 2 times the product of those sides, times cosine of the angle contained by those two sides. If I evaluate the right side of that equation, I get 274.1346849. That's what d squared is equal to. To get the value for d, I have to square root that number, and I get about 16.6 centimeters. The other time cosine law works is when you know all three sides of a triangle. We can use this version of cosine law, which is just the rearranged version of this, to get cos A by itself. When solving for angle A, we do its opposite side, so a squared, minus the squares of the other two, divided by -2 times those other two sides. So if I want angle A, I would say cosine of A equals, the side opposite from A has to come first, so 9 squared, minus the squares of the other two sides. The order of those two don't matter. So minus 11 squared minus 10 squared divided by -2 times those other two sides, 11 and 10. Simplifying the numerator gives me -140, and simplifying the denominator gives me -220. So I just have to do inverse cosine of that ratio to solve for angle A. And I get about 50.5 degrees. So there's the answers to all of the short answer questions on this exam. There is a section at the end that says answer 3 of the following 5 application questions. I'll do the first 3 of them, and then I'll show you the last 2 if you want to try them on your own as well. So 25 says the cost to rent a car is based on the number of days the car is rented and the number of kilometers it is driven. It says the cost for a 1-day rental and 240 kilometers driven is $39, but the cost for a 5-day rental and 900 kilometers driven is $165. We want to find the cost per day and the cost per kilometer. So I have 2 variables here. Let me define them. X equals cost per day and Y equals cost per kilometer. In order to solve for 2 variables, we have to make 2 equations. That's why I highlighted one set of information in green and one set in orange. From the green information, we can make an equation. I know that 1 times the cost per day plus 240 times the cost per kilometer should equal $39. So my first equation would be 1x plus 240y is equal to 39. Let me move this over here, and I'll write my second equation. From the orange information, I know that 5 times the cost per day plus 900 times the cost per kilometer should equal 165. To solve these simultaneous equations, I could use substitution or elimination. I think I'll use elimination. I'll make the x's have the same coefficient by multiplying this top equation by 5. When I multiply equation 1 by 5, I get 5x plus 1200y equals 195. I'll leave equation 2 as it is, and then subtracting these 2 equations from each other would eliminate the terms that have an x. 1200y minus 900y is 300y, and 195 minus 165 is 30. Isolate y by dividing both sides by 300, so that gives me y equals 1 over 10, which is 0.1, or in the context of this question, I'll write it as $0.1, which is 10 cents. So that means my cost per kilometer is 10 cents. I now need to take this answer I got from y, sub it back into either of my original equations, and then solve for x. So I'll make a little bit of room and then do that. I'll actually sub my answer for y. I'm going to sub it into my first equation. So when I replace this y with 0.1, I have x plus 240 times 0.1 equals 39. So x plus 24 equals 39. Subtract the 24 to the other side. I have x equals 15, which in this question means my cost per day is $15. My cost per kilometer is 10 cents and my cost per day is $15. Let's move on to question 26, which says a flagpole is secured with a guy wire. So here's the flagpole, here's the wire. The guy wire makes an angle of 65 with the ground and is secured 4 meters from the bottom of the flagpole. Part A says find the height of the flagpole. So I will label that as H. And because I have a 90-degree angle, I know I can use SOHCAHTOA to solve for a missing side of it. From this 65-degree reference angle, I'm going to label my opposite adjacent hypotenuse. I'm looking for the opposite side, and I know the adjacent side. The ratio that involves opposite and adjacent is tan. So to solve part A, I can say tan of 65 equals my opposite side H divided by my adjacent side 4. Isolate H by multiplying the 4 over, and I get about 8.6 meters. For part B, it asks me to find the length of the guy wire. So that is this side length here. So if I am looking for the hypotenuse, and the question gives me the adjacent, the ratio that involves adjacent and hypotenuse is cosine. So I could say that cosine of 65 is equal to 4 over the hypotenuse. I haven't given that a variable yet. Let me just call that x. So 4 over x. When my unknown is in the denominator, it actually just switches spots with the cos 65. So I have x equals 4 divided by cos 65, and that's about 9.5 meters. Let's do one last application question. This one has to do with a quadratic equation I can see. It says the path of a plane is given by this relationship where h is the height above the ground and t is the time in minutes. Part A says use the x-intercepts to make a rough sketch of the graph of the relationship. For part A, if I'm going to make a rough sketch of the graph, well, notice my variables are time and height. So my x-axis is time and my y-axis is height. In order to make a rough sketch of this, well, I see the a value is negative, so the parabola will be opening down. To get the x-intercepts, well, wherever it crosses the x-axis, notice the height is going to be 0. So to find the x-intercepts, I'm going to set the height to 0 and solve this equation. Because this equation is already in factored form, it's a product of 3 factors, I know that product would be 0 if any of the 3 factors were 0. This factor would be 0 if t was negative 20, and this factor would be 0 if t was 100. So my x-intercepts are at a time of negative 20 and at a time of 100. So a rough sketch of this would look like this. Part B says, at what time does it reach its max height? Well, here's its max height right here. And the question says, at what time does that happen? Well, notice the time at which that happens at is going to be right in the middle of the two x-intercepts. So I can find that time, or what we call the x-coordinate of the vertex, or the axis of symmetry, just by adding the x-intercepts and dividing by 2. That finds me the middle of the x-intercepts. 80 divided by 2 is 40. So I now know that that time is 40. So this point is the point 40 something. Part C wants to know what is that maximum height. So we need to figure out what is this y-coordinate of the vertex. And we could get that just by taking this 40 and subbing it in for the time in my original equation, and it'll give me the height. So part C, the height would equal, just sub 40 into the original equation for time, and I get 18,000, and the units we're in are meters. So that vertex is at the point 40, 18,000. So there you go. There are 3 applications done. If you want to try these other 2, just pause the video here. You can read that question, try it. Feel free to leave a comment with what you think the answer is. And the same with question 29 here. Pause that and give it a try. Leave a comment with what you think the answer is. Hopefully this video helped you get prepared for your exam for the grade 10 math course. Jensen